Let's start with box modeling. What makes box modeling its own type is that we will start with some primitive object such as a cube or sphere, and we use classic modeling tools to create a shape from it. We have a starting point and we work with low poly shapes to create our object. This is a common way of modeling that is quite mechanical since we control individual faces, edges, and vertices. With box modeling, we have an emphasis on manipulating whole shapes and larger portions of an object at a time. Most of the time, we work with faces that are four sides. We call them quads. These are easy to work with since most modeling tools are designed to work with quads. But before we use a model, it is often triangulated either by the user beforehand or automatically by the software under the hood. This type of modeling tends to work best with hard surface objects such as architectural visualization and man-made object or products. Polygon modeling. Polygon modeling is a type of 3D modeling that is quite similar to box modeling. The difference here is that we usually start with a single vertex or simple shape without an depth to it. Then we build our model piece by piece. We often use the same tools as with box modeling, but we use them in a kind of detailing way. The emphasis here is to work with edges and vertices a lot more. The type of objects we create with this technique still tend to be hard surface quite often, but with more organic shapes. Polygon modeling, like box modeling, often has an emphasis on using quads in the topology. This is because many tools are designed to work with a quad topology. This we create with polygon modeling may fall into the hard surface category, but many times the kind of models we create have some organic characteristics. It could be a statue or birding ornaments, for example, but it can also be some accessory, tool, or other gear that we created with this technique. Subdivision surface is often used here as well to smooth an object's geometry. Essentially, the tools used with box modeling and polygon modeling are the same. We just use them differently. Curve modeling. Curve modeling stands for non-uniform rational B-spline line. No wonder we have an acronym. With this kind of modeling, we switch to a completely different kind of modeling. We create curved surface that we control based on contour points. We can use it to create very smooth curved surfaces. We can both interpret between points within the same curve and also create bridges between multiple curves. We can set up a net of curves that act as the edges of an object, then fill in the geometry in between to create an object. This kind of modeling is mostly used in engineering and CAD like software, not so much when it comes to BFX and the art side of 3D. Imagine if you have an object that you want to 3D print. In this case, if you have a polygon model that we created with box or polygon modeling and you scale it up, all those faces and triangles will start to become visible, just like when you scale up a raster based image. On the other hand, with nerves, we can scale up and down the model and the curves will remain smooth. This could be said to be the equivalent of vector art and 2D graphics. Since we no longer work with vertices, faces, or edges and instead use curves, This means that the tools are very different. We may have tools that open or close a curve or create a new curve that interpret between two other curves. But we also have tools that are very similar like moving, control points, scaling, and rotating. Boolean modeling. With Boolean modeling, we start with a model and cut away or add other object to it to create a new shape. This is closely tied to box modeling, and we often use the two techniques together. Normally, we model basic shapes with box modeling and then combine different shapes with Boolean operations. The operation we have to work with are difference, union, and intersect. The difference operator is the most common. This is the operator that cuts away the shape and volume of one object from another. Union will merge two objects together, and intersect will save only the geometry that two objects share. Boolean can help us create shapes that would otherwise be time consuming to mimic with other modeling techniques. We can combine circular or bent shapes with square hard surface shapes and cut away or add these together. Procedural modeling. Procedural modeling come in many shapes and sizes. I will divide this in two different types of modeling. So the first one is tool based. We or someone else created a tool that is designed to procedurally generate a bunch of similar ay mali, procedural modeling. Procedural modeling come in many shapes and sizes. The first one is tool based. We or someone else created a tool that designed to procedurally generate a bunch of similar objects. For instance, we could have a building generator. We could then input a bunch of parameters like how many floors, how high the ceiling should be, and what kind of roof shape it should have. Then we run the program a number of times, and for each time through, a new model that follows our criteria is spit out. There are many such tools for specific types of models, and we can also create our own model generators and expose certain parameters that for the kind of model we want the tool to output.